Hello everyone, my name is Helen and I'm a solar scientist. I work at the University of Cambridge and I study the sun. I'm very interested in the sun, and today I want to share some things that I know about the sun. So here's a picture of the sun taken from space. And can you see there's a huge explosion on the right-hand side of the picture? So sometimes the sun is very quiet and sometimes it's very active and there's explosions, or we call solar flares, happen on the sun. But let me start by thinking about, what do you know about the sun? Why is it important to us? Well, the sun gives us everything we need for life here on Earth. It gives us light, it gives us warmth, it gives us energy, it makes the plants grow. Without it, we couldn't live. And what do you see when you look up at the night sky on a dark, clear night? You can see billions of stars. But those stars, many of them are just like the sun. The sun is just an ordinary star, like the stars you see in the night sky. So how old is the sun? Well, the sun is very, very old. That's 4.5 billion years old. That's 4,500 million years old. And here you can see a picture taken from the Hubble Space Telescope. And it's a picture of other stars being born, other stars just like the sun being born. It's called the Eagle Nebula. And it's a beautiful picture which shows the pillars of creation. So how big is the sun? Well, the sun is huge. It's really, really big. And can you see that little dot there in the center? That's the size of the Earth compared to the size of the sun. You could fit over 100 Earths across the middle of the sun, or you could fit 1 million Earths inside the sun. Jupiter there is a bit bigger. Jupiter's about 10 times the size of the Earth. So you could fit just over 10 Jupiters across the sun. And how hot is the sun? Well, the middle of the sun, the core of the sun, is very, very hot. It's 15 million degrees. That's really hot. Although the surface of the sun is about 6,000 degrees, that's still very, very hot. It's so hot that everything is a gas. And in that center of the sun, in the core, hydrogen turns into helium. And when it does that, a little bit of mass is turned into a huge amount of energy. And that's how the sun gets its energy, and that's how all the other stars get their energy. And the energy takes a little while to get out from the center of the sun. It travels out through different zones, through this zone here called the radiative zone, and then just beneath the surface, it's transferred by convection. If we look at the surface of the sun, we can see it bubbling away. Can you see it bubbling away there? And these like porridge on a cooker, and each of these little cells is about the size of France. So the hot gas is bubbling up to the surface. And these are beautiful pictures taken from a telescope called GSS, which is a very recent telescope that we have, and it's on in a beautiful place on Hawaii. So can we capture the energy from the sun? There are lots of ways we could capture it. And almost all of the energy we have here on Earth originally comes from the sun, but we can capture it directly. Can you think of some ways we could capture it directly? Maybe you've seen these panels of solar cells in fields or on houses, or maybe we could get a car which used solar cells to drive it along, or even on the wings of an aeroplane. And this is an aeroplane that's flown around the world called Solar Impulse. So what else do we know about the sun? Well, sometimes the sun has these dark spots on it. We call them sunspots, or spots on the sun. Can you see them? They're very spotty, that sun is. And this large group, when there's a lot of sunspots on the sun, then the sun is very active. As I said, sometimes it's sleepy and sometimes it's active, but when there's a lot of suns, it's very active and very angry, and it spits out explosions into space. And these explosions sometimes come towards the Earth, and when they do, it causes beautiful northern lights or aurora. Perhaps you've heard of those. And this little image down the bottom is spinning around. And it's spinning faster than the sun, but the sun does spin. The sun takes 25 days to spin around. Galileo, who you might have heard of, was one of the first people to study the heavens and the planets and the moon. And he was one of the first people to use a telescope to look up at the night sky. But he also studied the sun. Now, this is where I tell you, never, ever look at the sun, because the sun is far too bright and it will damage your eyes. He didn't look at the sun. He projected an image of the sun and he drew what he saw. And these are his actual drawings. And he saw these sunspots and he saw the sun spinning. As I said, it takes 25 days to spin around. Galileo often got into trouble for what he said because other people didn't believe he was right. They didn't believe what he said was right. From his observations, he said that the Earth goes around the sun. Now, we all know that the Earth goes around the sun and the other planets go around the sun. So you might think, well, why did he get into trouble? But at that time, people didn't know that, and they thought that everything went around the Earth because the Earth is so important that everything else must go around it. So he was kept under house arrest. It's a little bit like the lockdown we've just had, where we have to stay in our houses a lot of the time. And that's the view from his house in Italy. And perhaps some of you know what this is. This is called a total eclipse of the sun. And it happens when the moon goes between the Earth and the sun. Now, the sun is very bright, as I said, and you must never look at it. But when the moon blocks out the sun, you see this disk around the sun. It's a crown of light around the sun. And this crown of light, which we call a corona, is not as bright as the disk. The disk is a million times more bright. So the moon exactly blocks it out. Now, the moon is smaller than the Earth, but it's closer to the Earth. So it's able to block out the sun, even though it's much smaller than the Earth. But it's quite frightening. When a total eclipse happens, it goes dark and cold. And people in days gone by didn't understand what was happening. They were very frightened. And here you can see the Chinese were so frightened, they thought that a dragon was eating the sun. And they frightened the dragon away by making lots and lots of noise. So they banged pans and made a lot of noise to frighten the dragon away. I'm sure a lot of you have seen a rainbow. It's very beautiful when the sun is behind you and there's raindrops in front of you, and the light breaks up into the beautiful colors of the rainbow. Now, somebody else you might have heard of is another favorite scientist of mine called Sir Isaac Newton. And he studied gravity. If you remember, he watched an apple fall from an apple tree. And he asked a very simple question. Why did that apple fall down? Why didn't it stay in the same place? Or why didn't it go up? Do you know the answer to that question? He thought about it very carefully. And at that time, people didn't understand why that happened. And from that, he worked out the laws of gravity and the laws of motion and why the Earth goes around the sun, why the planets move, how we move, why we stay on Earth rather than floating around in the room. But he was also interested in light, and he studied the colors of light. And he realized that the light that we can see, that we call the visible light, is made up of the different colors of the rainbow. But there is some light that comes from the sun that we can't see if we go beyond the colours of the rainbow. For example, beyond the violet, we get something called ultraviolet. Now, we have to be very careful when we go in the sunlight because we don't want our skin to burn, and we have to put sunblocker on or protect our skin or protect our eyes. We have to protect our eyes from the brightness of the sun, but also from the ultraviolet light that comes from the sun, the UV light. And here we've got some beads which respond to the ultraviolet light. So when they're indoors, they're very boring, they're just white. But when you go outside, they change color because they respond to the UV light or the ultraviolet light. Now, I use satellites from NASA, and perhaps you've heard of NASA, and ESA is the European Space Agency, and I and other scientists use satellites in space to study the sun. We look at it with lots of different instruments on the satellites to study the inside of the sun, to study the atmosphere of the sun, that corona, and to study gas that flows off the sun into space. So SOHO was launched about 20 years ago, and we've been using it to look at the sun. That's just one of the satellites that I use to look at the sun and to study the sun. Here's a huge explosion on the sun, and you can see the Earth is quite small in comparison to that huge explosion that's taking place on the sun. That's from a satellite called the Solar Dynamics Observatory. And here you can see explosion taking place and shooting out into space. Did you see that lifting off? I'll play it for you one more time. Here you can see it lifting off and shooting into space. That's an eruption, or a lot of material that flows out from the sun into space. Now, sometimes that can go in all different directions, but sometimes it can head towards the Earth. And when it heads towards the Earth, it can cause these beautiful northern lights that we see. Our Earth has a little bit of a protective layer around it, a little blanket protects it a lot, but sometimes it can be disturbed, and sometimes very energetic particles can shoot into the atmosphere and cause these lights because they excite the atmosphere and make these beautiful colors. But these particles that come from the sun, these bits of material that's coming from the sun, can also be harmful because they're moving very fast. They can be harmful for astronauts if they're in space. They can damage satellites. They can cause electricity blackouts. So we want to understand them. We call this space weather. It's a bit like normal weather, but it's space weather. It's what's happening on the sun that affects us here on Earth. Now, did you know who was the first person from the UK to go up into space? It was a lady called Helen Sharma, and there's a picture of her. She went up in 1991 on the Russian space station Mir. And quite funny because before she went up, she worked in the Mars factory. I don't know whether you've ever had any Mars bars or maybe Mars ice cream, but that's what she did. She was a chemist, she was a scientist, and she worked in the Mars factory. And she was driving home one day and she heard an advert on the radio saying, astronauts needed. And she said, I'd quite like to do that. And she had to try very hard, and she was selected and went up into space. But perhaps you've also heard of Tim Peake, and he was an ESA UK astronaut who went up into space about 2015. And here you can see he's doing a spacewalk. Well, what was he doing on it? You can see the flag there for the UK there. What was he doing on his spacewalk? Well, he went out to mend these solar panels, and these solar panels are picking up energy from the sun to make electricity for the International Space Station. He was very lucky when he was in space. One of the things he really, really wanted to see was the aurora from the International Space Station, and he was able to see that many times, so he was very happy about that. So recently we've launched some more spacecraft which are going very close to the sun. One is called Parker Solar Probe, and that's a NASA satellite, and one is called Solar Orbiter, and that's an ESA, European Space Agency satellite. So those are going to help us to understand how the sun interacts with the Earth much better. Then finally, I want to say we work on a project which brings science and art together, and we think about the sun, and we think about the solar system, and we think about space, and we think about ways in which we can paint or draw or make beautiful artwork connected with that. And here you can see a beautiful dress. It's called the Sundress for the Yellow Giantess, and it's made by Helen Shell, the artist. So thank you very much for listening.